Okay. So there are a few points regarding the characteristics of equilibrium constant, and I don't think that they need explanations because we have done and we have applied these same concepts in questions. So you may know this, like equilibrium constant is applicable only when concentration of reactant product have attained their equilibrium state, right? Because we said that otherwise we have this word that is reaction quotient, and at equilibrium we have the equilibrium constant. Okay, then the value of equilibrium constant will be independent of the initial concentration because it is going to be a ratio. Whatever the initial concentration you took, it is not going to affect the equilibrium constant. Then equilibrium constant has a definite value for every reaction at a particular temperature, and because you know that if I increase or decrease the temperature, that means it is also going to alter the number of products and reactants. So at a particular temperature, you will have a particular value of equilibrium constant. And also see it, if you remember equilibrium constant, it is coming up from the rate of reactions, right? So rate of forward is equal to rate of backward reaction. So if I will increase the temperature, what is going to happen? If you have more number of moles here, for example, A plus B is here, so they will be colliding more often. And that is going to change the number of collision, and that is going to change the rate. And that is why it is also going to change the equilibrium constant. Okay, so temperature is one factor that affects the equilibrium constant. Then you have, for a reversible reaction, the equilibrium constant for forward reaction is inverse of the equilibrium constant of the backward reaction. So if you look at this reaction, let me write it like this. If I talk about A to B, then you will say that equilibrium constant, it is equal to the concentration of B divided by the concentration of A. But if I talk about B to A, if I write the equation like this, then you will say that the K inverse, let us say that is K dash, equilibrium constant for this equation will be equal to the concentration of A upon the concentration of B. So the relation between K and K dash is that this K dash is the inverse of K, right? Yes or no? Please tell me.
Yes, sir. Yes, sir.
So these are simple points of equilibrium constant that that needs to be there in your notes, and you have like slight idea what are these saying. So K forward will be equal to K of backward, and equilibrium constant, we have already said this, that it is independent of the presence of catalyst. If catalyst is there, it will be achieved earlier, but that constant, the value is not going to change. The value is not going to change. Okay, so I don't think you have any doubt till here. Maybe you can flip a bit of pages and tell me if you have any doubt. Otherwise, I can proceed. Okay, so I don't think you guys have doubt. Yeah, tell me, guys. I can proceed, no? Yes or no?
Yes, sir.
Okay, fine. So please, Anna, now answer me. You guys have to answer me. I'm giving you some situations. Anna, we'll start with a very simple situation. Please keep your mics on, okay? When I ask you questions, try to give them answer. Anna, jaldi jaldi khatam karenge fir isko. Okay, I have A and it is giving me B, and these are in equilibrium. These are in equilibrium, and let us say that the K here it is equal to K here it is equal to 1. K here it is equal to 1. Okay. Now, initially, let us say we have 5 moles of A and 5 moles of B. So tell me, guys, will there be any change if I have this condition?
No, sir.
No, there will be no change, right? There will be no change. There will be no change. Okay. Now, let us say that what I did, a human made some changes here. A human, so the equilibrium, two types of changes will be present. If you start with K which is not equal to Q, then there will be some changes made by the system itself. The system itself will change. For example, if I started with, let us say I started with 10 moles of A, then human is not doing anything. The system itself is changing a few things. It is converting into B. But let us say I started with 5 and 5. Now the system is not going to do any changes. So what the human I did, I increased the number of moles of B, and I added, let us say, I added in this, let us say 3 moles. 3 moles of B I added. Now the condition is 5 and 8. Now you tell me, will there be any change? Let us say, wait a second. 2 add kar diya humne isme. So now we have 5 and 7. So now you tell me, guys, will there be any change now?
Yes, sir.
Yes. What will happen?
It's a backward reaction.
Backward reaction will happen. All of you agree with this? Yes or no? Razan, Minashi, Saeed Muhammad, Yusra?
Yes, sir.
Yes, no? Backward reaction.
Yes,
will happen.
sir.
So see, so if backward reaction will happen, that means there will be a decrease in the concentration of B. Yes or no?
Yes, sir. Yes, sir.
Right.
Yes, sir.
So this is something that human did. This is something that we did. Hai na? So what did we do? We tried to increase the moles of B. Hai na? I tried to increase the moles of B, and this is there is some change that the system is doing. System, what did it do? It tried to decrease the moles of B. Yes or no? Right, guys? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Now, so whatever we are going to do, if I'm at equilibrium, now we are talking that after we have achieved equilibrium, and if I want to disturb that equilibrium, so whatever disturbance that the human is creating, the system, it will change its direction, or it will move towards a particular direction where the disturbance has been lowered. So if I try to increase the number of moles of B, the system will try to decrease it. If I try to decrease the number of moles of B, the system will try to increase it. If I try to increase the number of moles of A, what will the system do? System will try to decrease the number of moles of A. And if I try to decrease the number of moles of A, the system will try to increase the number of moles of A. And obviously, the system has only got two choices. Whatever change I make, I can increase the number of moles of B, I can increase the number of moles of A, I can decrease the number of moles of B, I can also decrease the number of moles of A. But the system has only two things. It can either go forward or it can go backward. It doesn't have any other choice. Whatever change I am doing, it has to minimize that change. It has to bring about a change in the opposite direction by either going forward or going backward or going backwards. Okay. So whatever change I am doing, whatever change the human is doing, it will be led by a change that is done by the system. The system will either move forward in the forward direction, or it will move in the backward direction, So is this point clear? Yes or no, guys? Tell me.
Yes, sir.
Okay.
Yes, sir.
Now, next thing that I want to tell you, let us also discuss this. Next thing is that, let us say that A gives, now it is reversible, B, and it also gives some heat out. So we have here forward and here we have backward. Okay. So the forward reaction in which A is converting to B and giving out some heat, that is an exothermic reaction or an endothermic reaction. The forward reaction is exothermic or endothermic? Yeah, guys.
Exothermic.
Exothermic, right? Yes or no? Minashi, Razan, because it is from A to B, it is giving B and also some heat. All of you can see that? Yes or no?
Yes,
Yes,
sir.
sir. Yes,
Yeah,
sir.
all of you can see that. Very good. Now, now you tell me, the heat is in the product or reactant?
Reactant.
Acha. What is a reactant? What is a product? So let me just define that. So reactant is anything. A reactant is something that is on the left side.
Sorry, sir. Product.
Product है ना?
Yeah.
आपने गलती से बोल दिया ना?
Yes, sir.
अच्छा. Product is something that is on the right side है ना? इसका कोई मतलब नहीं है. Please remember that when we talk about reactant and product, we just mean we have this arrow and what is left towards the arrow and what is right towards the arrow. इसका original experiment से कोई लेना देना नहीं होता है. Okay, it doesn't have to do with anything with the original experiment. Reactant is something that is on the left side of the reaction arrow, and product is something that is on the right side of the reaction. So obviously, heat is one of the product. Okay, heat is one of the product. And we have established earlier that if I increase the product, then reaction moves backward. Yes or no? We have proved this earlier. Yes or no?
Yes, sir.
Yes, all of you agree? Yes or no? Minashi, Razan, Khalil?
Yes, sir.
Yes, sir.
No? Okay. Now, let me ask you, what will happen what will happen if I increase the heat? If I increase the heat, what is going to happen? I'm increasing one of the product, and if I'm increasing one of the product, the reaction will move backward. Is that clear? Yes or no?
Yes, sir.
If I give it heat, if I give more heat, that means what I do, if I increase the temperature, if I increase the temperature here, then what will happen? Then the reaction will move backward. And this is very more specifically what I can say. Here, the forward reaction, here we have the forward reaction, and here you have the backward reaction. So the forward reaction is exothermic. The backward reaction is endothermic. I think you can see that because B plus heat, it is going to give me A. So B is endothermic. So exothermic, and we have endothermic. So endothermic reactions, these are favored at high temperature. Because what is happening when I am giving it heat, it is going, the backward reaction is happening. So it is favored at high temperature, giving heat, and I can give heat by increasing the temperature. And exothermic is favored at low temperature. So that means if we have an exothermic reaction, and if I increase the temperature, that means the exothermic, it will not be the exothermic reaction will not be favored at that point of time. The exothermic reaction will slow down. If I heat the system, the exothermic reaction will slow down. Okay, so these are the 2 points, and all of this point now, and the basic idea that we said, that whatever change the human is giving, we have some change that is given by human, then the system also gives some changes. The system also gives some changes, and that change is what? And that change is what? It is only present to minimize the change that was given by the humans. And this concept that we just understood, it was given first by Lee Chatelier. It was first given by Lee Chatelier. Okay, so we will look at the statement what Lee Chatelier said, and obviously it is not going to be as casual as what we said. He has to write it and he has to polish the whole statement. So it is kind of I can say confusing at first, but when we read it word by word and we understand it point by point, then it will not be much of a big deal. Okay, so Lee Chatelier principle, again, I'm not going to write this thing down because I can just copy and paste that thing. Yeah, so let me just write here. Lee Chatelier's principle. So it is just what we have understood right now. Okay, see, he start with a system that is in equilibrium. Yes or no? If a system in equilibrium, first of all, he established that we have an equilibrium, and that is also the first thing that we did here. We started with A and B, who both are having 5 moles, and the K is equal to 1. When the K is equal to 1, is subjected to a change. Now see, is subjected to a change, and no, who is doing this change, guys? Who is doing this change? Human or system? Human. And our first change is done by human in any of the factors that determine the equilibrium. See, any of the factors that determine the equilibrium. So concentration determines the equilibrium, and then temperature determines the equilibrium. So whatever factor he is saying that it determines the equilibrium condition of a system, then the equilibrium will shift. Now who is doing this shift? This shift is done by system or the human?
The system.
System. Shift in the direction so as to reduce or to counteract the effect of the change. That means it has to minimize the change. So you can read this, and I hope it makes sense. So you start with the equilibrium, then there is a change that is done by human, and then that change is what? That change is minimized by this the system that is in equilibrium, and we can only minimize by either going forward. Not we, sorry. The system can only minimize by either going forward or going in the backward direction. Okay. So we'll first start to write that what will happen if we change the concentration. So factors that affect the equilibrium constant. So number 1 is the concentration. So we have two things. We have reactants. Okay, so we can do either we can increase the concentration of reactant, or we can, this is the change that is done by human, decrease the concentration. Now, if I increase the concentration of reactant, then what is going to happen? It will move towards the forward direction. Move towards forward direction. And if I decrease, then, because see, when I increase the number of moles of, when I increase the concentration of reactant, we have more reactant. So system want to reduce reactant, so it will move the forward direction, and it will convert the reactant into product. It will convert the reactant into product. And if I decrease the number of moles of reactant, if I decrease the concentration of the reactant, then what is going to happen? Then the system will try to increase, and to increase it, I have to move backward. I will convert the product to reactant. Will go to backward direction. Backward direction. Okay. Next is products. So in product also I can either increase. So this is the change that is done by human, and what it leads to backward direction. The equilibrium shifts to backward direction, and when I decrease, then it goes to forward direction. It goes to forward direction. Next is we have temperature. Next is we have temperature. In temperature. Okay, wait a second. Let me give you guys a question first, Hannah. Then we will move to the temperature. Yeah, please write this down. Write this question, Hannah. Guys, did you write the question, yes or no?
Yes, sir.
Yes, sir.
Okay, so can you please turn the mic on and tell me what will be the effect? And effect means whether the reaction will move forward or backward. Anna? The effect means what will happen to the reaction, whether it will move forward or it will move backward. So addition of H2, what will happen? Forward or backward? H2 is a product or reactant?
Forward.
Yeah.
Forward.
Forward. Okay, addition of CH3OH.
Backward.
Backward.
Backward. Very good. Removal of CO. We are removing CO.
Backward.
Backward. Very good. Backward. And removal of CH3OH.
Forward.
Forward.
Forward, है ना? Very good, guys. Okay. Next is the temperature. Okay. So in temperature, we can either increase the temperature or decrease the temperature. If I increase the temperature, then it will shift towards endo reaction. Endothermic shifts towards endothermic reaction. And if I decrease it, it will shift toward exothermic reaction. Okay, so this is about the temperature when I increase or decrease it. Okay, when I increase or decrease it. Now I can also say about if we have an exothermic reaction, we have been given a exothermic reaction. For example, if you have exothermic reaction, so what will happen if I increase the temperature, and what is going to happen if I decrease the temperature? Now, for an exothermic reaction, if I increase the temperature, now please remember when I say exothermic reaction, that means it is this type of reaction. Okay, this type of reaction in which in the products we are having, we are getting some heat in the product side. So what is going to happen if I increase the temperature? If I increase the temperature for this, then it is going to move in the backward direction. And if I'm going to decrease the temperature, it is going to move forward. It is going to move forward. If I have an endothermic reaction, it will be something like A plus heat is going to give me B product. Okay, A plus heat is going to give me B. So in this case, if I increase the temperature, it is going to move in the forward direction. And if I decrease the temperature, it is going to move in the backward direction. Okay, in the backward direction. Any doubt in these points? Yes or no, please tell me.
No, sir.
Have you any doubt? No.
No, sir.
No, sir.
Okay. Next is let us see the effect of change in volume. Okay, effect of change in volume. So temperature was what, second? This will be third. Change in volume. Now, let us talk about now change in volume. How does volume how does volume affects the equilibrium constant? So for that, I will just relate concentration to volume. So what is concentration? Now molar concentration, because in equilibrium we use molar concentration. So molar concentration is number of moles divided by volume. So we can say that concentration is inversely proportional to volume. Yes or no? Correct, guys?
Yes, sir.
Yes, sir.
Yes, sir.
It is inversely proportional to volume. Now, if I decrease the volume, the concentration will increase, right? The concentration will increase. Now, also one more thing we can write, that if I talk about volume, it is PV is equal to nRT and pressure is equal to nRT upon V. So it has a similar relationship for both Kc or Kp, whatever you are going to write. Even if I talk about the concentration in terms of molarity, or we talk about the pressure, both are what, inversely proportional to volume. Both are what, inversely proportional to volume. So we can talk about the effect of change in volume in terms of both of them, and they will have this. They will have a similar type of change. Now, if I increase the volume or decrease the volume, what is going to happen? Okay, wait a second. Before volume, I have to tell you about the pressure part, or can I tell you about the? Okay. Let me talk about this first. Now tell me what is going to happen if I decrease the volume. Will there be more association or more dissociation? So you can see if I go from reactant to product, there is association because nitrogens and hydrogens, they are attaching themselves to make ammonia. And if I go from here, there is dissociation happening. Hai na? So now you can tell me what is going to happen more if I decrease the volume. More association will happen or more dissociation will happen?
Dissociation.
If I increase the volume, then more dissociation is going to happen. Wait a second. Just Khalil, tell me. This is the change that I'm talking about, hai na? Decreasing the volume. So if I decrease the volume, things will stick together or they will move apart.
Just stick together.
So association or dissociation?
Association.
Association. Is everyone clear with this? Yes or no?
Yes, sir.
Okay. Now, as I'm decreasing the volume, I'm also increasing the pressure. Yes or no?
Yes,
Yes or no? So both of them will have a similar type of effect. Now see. So what happened when I increase the pressure or I decrease the volume? What is going to happen? We are moving towards that side which has less number of moles of gas. Yes or no? Right, guys? Can you see
Yes, sir.
that we said association, but in order to quantify it and in order to predict what is going to happen by just looking at a particular reaction, then I can say that I will move towards a direction in which we have less number of moles of gases, So I can talk about both of these things, the effect of pressure and the effect of volume in the same term and with the same reaction. Let us talk about first of all the pressure, effect of pressure. So if I increase or decrease the pressure, hai na? So there is pressure here. Now I can either increase the pressure, the human is going to increase the pressure. Now if it is going to increase the pressure, then there will be more associations. And that will lead to the shift of equilibrium towards less number of moles of gas. And when I am going to decrease the pressure, there will be less associations, and that will lead to shift in equilibrium towards more number of moles of gas. Is this clear with everyone? Yes or no?
Yes, sir.
Okay, but let us see if we have some H2 plus I2. H2 plus I2, both are H2 plus I2. I2 may be solid also. So I can say H2 plus Br2, both of these are gas, and they give HBr. HBr is also gas, 2HBr. Now in this case, I can see that here you have 1 mole of H2, 1 mole of Br2. So essentially we have 2 moles. And here also we have 2 moles, right? So there is no association, no dissociation happening here, right? Because initial also we have 2 mole, in the final, in the reactant also 2 mole, in the product also we have 2 moles. So in these cases, when we have the equal number of moles of gases in both reactant and product, the pressure has no effect. For a reaction, in which the number of moles of gases in reactants and product are same. Change in pressure has no effect. Change in pressure has no effect. Okay. Next is effect of change in volume. This is going to be fourth, I think. Shows third. Volume. So we have volume. I can either increase or decrease it. If I'm going to increase it, then it is going to be less association. That will lead towards if I increase the volume, I can have more number of gases now towards more number of moles of gases. If I'm going to decrease it, then the system will have more association. And then it will lead towards less number of moles of gases. Okay, less number of moles of gases. Now, at last we have effect of addition of inert gas. Effect of addition of inert gas. So there are only two main things Either we can have change in the concentration. Change in concentration. If the equilibrium concentration changes, then we'll have a different equilibrium constant and we will have a different state of equilibrium. We will have a different state of equilibrium. So, or we have temperature. These are the only two things that affects temperature. Please remember, change in concentration means it doesn't mean initial concentration, it means the equilibrium concentration. If the equilibrium concentration somehow changes, then there will be some change in the equilibrium state, or there will be, or if we have any temperature, or if we have any change in the temperature. Now, in the last case, let us see. There is some reaction going on. And in this reaction, I added an inert gas. Inert gas that will not react with anything. Yes or no? So in a closed container, I added an inert gas. Now tell me, guys, what is going to happen? If I add an inert gas in a container, then the pressure of container will increase. Yes or no?
Yes, sir.
The pressure is going to change. The pressure is going to increase. Right? Now, please, but remember that the pressure is going to change. We're going to change the pressure. But whatever the concentration was of individual gases, that is not going to change because we are not changing anything in the concentration. We're not changing the number of moles. Right? Now, that means if I put inert gas at constant volume, and see the volume is constant, right? So volume is constant. Then we have the number of moles of reactant and the product. So reactant and product, these are also constant. These are not going to change because we have added an inert gas. Inert gas does not react. If it does not react, that means it is not going to change the number of moles of reactant or the products. Neither the volume is changing. Now, if the concentration is not changing, the volume is not changing, then obviously, if I add an inert gas at constant volume, it will have no effect. It will have no effect because there is no change in concentration and there is no change in the pressure. No, it doesn't mean that the overall pressure of this container. No. I mean the pressure that is applied by the individual reactant and product, the partial pressure. I'm talking about partial pressure. But let us say if I have a container like this, if I have a container like this, and here is a piston, and this piston is movable. This piston is movable. So we can move this piston up and down. Now, obviously, if I have this piston here and I add an inert gas, so that inert gas is going to take up a volume. And what is that inert gas going to do? Will it raise up the piston or it will go down? What will happen to the piston? It will raise up or down if I add inert gas. Just tell me, guys.
Will go up.
It will go up. Now it will go up. Now there's a change in volume, yes or no?
Yes, sir.
There's a change in volume. Now please remember that when we were doing this reaction, so if this piston is movable, that means this piston is movable. It means that it is maintaining a constant pressure because it does not want to increase the pressure. If I added inert gas and if it stayed here down itself, that means the pressure would have increased. So it slowly increased the volume so as to make the pressure constant. So we can add an inert gas either at a constant volume, or I can add an inert gas in this case at constant pressure. Now, if the pressure is constant, the volume is going to change. And if the volume is going to change, that means it can alter the concentration, because concentration is nothing but number of moles, which is not changing, but volume it is changing. Number of moles is not changing, but volume is going to change. So if we add inert gas, then the volume is going to increase. The volume is going to increase and the concentration is going to decrease, right? So if the volume increases, what happens? We know that there is less association and it moves towards more number of moles of gases. Okay, so let us talk about inert gas. Addition of inert gas. This is the last one. I think this is the fifth one. Yeah. Inert gas. Okay. So you had inert gas. You can add inert gas at constant pressure or at constant volume. So at constant pressure, if I add, then the volume increases and the equilibrium shift towards more mole of gases. At constant volume, no effect. Okay. At constant volume, there will be no effect. Okay, tell me, guys, is this fine with everyone? Addition of inert gas, yes or no?
Yes, sir.
Yes. Okay. So just let me fetch a question on. I think there is one in NCERT. So let us cover that first. Yeah, so you can just look at the reaction that is happening here in the board itself. Don't write this and we can answer it. Hai na? So the questioner is asking which of the following reaction will be affected by increasing the pressure. Okay, which of the following will change increasing the pressure? So you have to just remember this point. Sorry, where did the pressure go? Sorry, I pasted in the wrong batch, I guess. Yeah. Okay. Can you see this now?
Yes, sir.
Okay. Were you able to see the previous one? No.
No, sir.
Oh, okay. Same. So for pressure, you just have to see that for a reaction in which number of moles of gases and reactants and products are same, change in pressure will have no effect. Okay, will have no effect. So look at the first reaction. How many moles of reactant are there? How many moles of gases and reactant in the first one?
Equal, sir.
In the first one, how many moles of in the reactant? How many moles of gas is there?
2.
1.
1 mole. And in the product, how many moles?
2.
2. In the products, we have 2. So this will be affected, right? Yes or no? This will be
Yes.
affected, yes or no?
Yes, sir.
Yes, sir.
And it will move towards more moles or less moles if I increase the pressure. If I increase the pressure, the volume will shrink, yes or no? There will be less volume available.
Less number of moles.
So if there is less volume, we can hold less moles. So this will be, it will change and it will move in the forward or backward. It will go backward. You got a gist, yes or no, guys?
Yes,
Yes,
sir.
sir.
Okay. What about the next one? Tell me.
So no change.
No change because we have no change, equal number. Here also 3 moles, here also 3 moles. What about the next one?
No change, sir.
Why? How many moles of gas in the reactant? How many moles in reactant? How many moles of gases in reactant?
Two.
Yes, Yusra, Khalil, Minashi, Razan, say
Sir, 2.
how many?
1.
1, na? 1 mole of gas, na? Only CO2. And in product?
2.
2. So there will be a change, na? So now tell me, which side? Less moles or more moles? So increasing the pressure, obviously it is going towards less number of moles of gas. So forward or backward? Just tell me that. Forward or backward?
Backward.
Backward. Next is fourth one. Tell me. Change, no change. अच्छा वो छोड़िए, reactant में बताइए आप लोग. How many moles of gases in reactant? How many moles of gases in reactant? अरे why you guys are not seeing it? बस पढ़ना ही तो है. क्या काउंट करने में इतना टाइम
Two,
लग रहा है
sir.
आप लोगों को? How many? Sayyid Mohammed, can you please repeat that? अरे बोलिए, खलील बोलिए, मीनाशी, रजान, कोई भी
3,
बोलिए.
sir.
3. And product?
1.
1. Forward or backward? Forward or backward?
Forward.
Forward.
Just wait a second. Yeah. Okay. So now in the fifth one, tell me. How many moles of gases in reactant?
0.
0. And product?
1.
So forward or backward? Less number of moles?
Backward.
Backward. Now in the reactant, how many moles of gases in reactant?
9.
9. And product?
10.
10.
10. So forward or backward?
Backward.
Backward.
Backward. Okay, fine. So you guys have got it. And just let me give you one more. That will be your homework. Okay. So you will do this question. This will be your homework. Okay, so actually you can do more questions. 7.30 also you can do. With the following reactions. Maybe you will do more questions. I think you can do more questions till 7.34. I think you can do 7.34. So 2, 3 to 3, 4. इसको छोड़िए आप. So homework will be NCERT exercises. So you did till 7.24 now. So you can start with 7.25. What is 25? Yeah, that is also similar type of question that we discussed today. Okay, so 7.25 to 7.34, है ना? So I don't think in these things you will have much calculations. ऐसे सवाल है ना, forward backward बस बताना है. So like not the previous type of questions that we did. And then tomorrow we will start ionic equilibrium. Okay, ionic equilibrium. And see, अगर आप लोग 7.34 तक कर लीजिएगा, then we are exactly like on half, I can say. आधा हो गया chapter. We have 7.73 questions है. Then you can at least remove 3 questions because they will be out of the syllabus for this term. Na? Here